on limiting reactants. And so I have a sample problem up here, and we're looking at N2 plus 3H2 giving us 2NH3. So this is kind of looking at nitrogen and hydrogen mixing to make nitrogen trihydride. In this, we are given 6 moles of nitrogen and 12 moles of hydrogen. That's what we were told from our problem. So to do a limiting reactant problem, what we're looking at is getting information from both of our reactants, and we're going to end up using all of one and only some of the other. So we're trying to identify which one is going to be used completely and which one is going to be left over. So we work these out like a normal BCA table to start. We have our balanced chemical equation, and then we put these in for the before. So we have 6 moles here and 12 moles here, and we haven't created any of our product yet, so that's a 0. Now in the change, we need to figure out, are we going to use all of our nitrogen, or are we going to use all of our hydrogen? So what this looks like is we have one N2 particle, and we have 3 O2 particles make 2 NH3 particles. Okay, so for every one of these I need 3 of these. So let's look if we start with using the nitrogen. If I use all 6 of the nitrogen, I would need 3 times that many of the hydrogens, so that would be 18. I would need 18 particles, or 18 moles of H2. I don't have 18, I only have 12. So if we use all 12 of the hydrogen, well, for 3 of the hydrogen, I need 1. So of this 12, I would only need a third of those, so I'm going to divide and end up only using 4 moles. This can also be done with a proportion. So 6 moles of nitrogen over X moles of hydrogen equals 1 mole of nitrogen over 3 moles of hydrogen. If we cross these out, we'll find that we have X times 1 equals 6 times 3, and that equals out to 18. Here we have 12 moles of hydrogen over X moles of nitrogen equals 3 moles of hydrogen over 1 mole of nitrogen. If we do our crisscross, we have X times 3 equals 12 times 1, divide both sides by 3, and we end up with X equaling 4. So what we're going to do is we're going to use up all of our hydrogen and have some nitrogen left over. So I'm going to use up all 12 of this. If I use 12 of these, I only need 4 of these. So I'm only going to subtract away 4, but we need to figure out how much of the nitrogen trihydride we're going to make. So if we use 12 moles of the H2 over X moles of the NH3, that's the same as saying 3 moles of the H2 over 2 moles of the NH3. And if we do our crisscrosses, we end up with X times 3 equals 12 times 2, divide both sides by 3, and our X equals 8. So we are going to make 8 moles of the NH3. So afterwards, we have 2 of the nitrogen left, 0 of the hydrogen left, and we have made 8 moles of our product. So our excess is nitrogen, and our hydrogen is our limiting reactant, and this is our product. From here, we can do lots of information. So, for example, instead of getting these moles as information from your problem, you could have been given in grams. If we start with grams, we're going to have to do the molar mass to convert to moles first. Or you have these in moles of your product, and maybe the question is asking how many grams of NH3 are going to be produced. Again, you're going to have to use the molar mass to go from moles to grams.